Sometimes intelligent people will come up to me and say, Alan, you're so good at math and physics. How are you so smart? And I never know how to respond. On one hand, I want to express a level of deep gratitude. One can't hope for a better compliment, and I'm truly thankful for it. On the other hand, if I say thank you, it's like I'm agreeing with them in a very narcissistic way, as if they were justified in complimenting my intelligence. Usually I just avoid the whole subject entirely and point out a few of my shortcomings, of which there are many, in an attempt like trying to prove that I'm not actually smart. But they ask a challenging question. How and why do I think the way I think? Is it somehow different than everybody else? How does one acquire a mindset? And what constitutes a smart mindset? These are non-trivial questions, and I think they warrant a discussion. The problem is, many people jump to conclusions when they think of so-called smart people. First, they think that they're natural geniuses, bestowed at birth with some great gift of intelligence which will forever transcend the efforts of normal people. Secondly, they think that smart people live, breathe, and eat math and science, never ceasing from homework, never taking a break, and never actually living. In both of these scenarios, the other person sees smartness as inaccessible. In the first case, it's hereditary, so they don't and never will have it. In the second case, they rightly think that sacrificing their life to studying is simply not worth it. I want to claim that these are misconceptions. Intelligence is not some nebulous concept floating around the collective subconscious. It's not something that requires an inhuman amount of effort. It's a concrete skill, something that's learned. And I claim that this skill is logic. But it's a subtle and sophisticated kind of logic that permeates an entire intellectual experience and leads not just to technical correctness, but ultimately creativity. Ironically, I think some of my intellectual core comes from a backlash against my school's attempt to teach logical thinking. In fourth grade, soon after our school had adopted this new curriculum of logical thinking, our teacher told our math class of 6 that we were going to race potatoes. So we were each given a potato, and we headed out to the playground. There I set my potato along with the other 5 at a white chalk starting line. And about 6 inches to the right of each potato was a little square gate, about 6 inches on a side. And this was the finish line, apparently. And the one rule was that you couldn't touch your potato. And then the race started. I remember sitting there feeling distinctly underwhelmed. We were all literally sitting around watching potatoes, waiting for absolutely nothing to happen. So in the end, we figured out that in order to have won, we would have had to move the finish line to the potato. And I remember this feeling incredibly unfair, and years later, I recognize why. In a race, the finish line never moves. If you look at bike races, marathons, NASCAR, the Olympics, the goal line is always clear and immutable. So when our teacher framed the activity as a race, he introduced a set of implicit constraints, one of which is that the finish line doesn't move. So when we learned that the solution was to move the finish line, we felt cheated because we were cheated. We had made a reasonable assumption about the game, and the resulting rule was violated. Logic is all about moving within constraints. It's about testing the very limits of those constraints, but always staying within the rules. What many people don't realize is that the constraints we are given are intimately tied to the humanity that they came from. So although logic itself is pristine and unchanging, translating words and speech into a set of clear constraints is as much a skill as logic itself. Unfortunately, my fourth grade experience wasn't teaching logic. When the curriculum was simplified and watered down for fourth graders, the idea of implicit constraints was left by the wayside. And in a subject defined by specific, coherent, and unbending rules, simplification is as much a disservice as it is a benefit. Imagine what would have happened if our teacher had used the opportunity to explain to us what the idea of an implicit constraint was and why it never even occurred to us fourth graders to move the finish line to the potato. Maybe that would have been too complicated. But I think if we taught it again and again, in lesson after lesson, we could succeed at teaching implicit constraints. But this isn't the only thing we can teach at a young age. The precise language used in logic is not some pedantic construct of an elite group at the top of the ivory tower. It's the same language we use in speech, in argument, and indeed in conversation. One especially tricky example, and one that I didn't fully understand for a long time, was the idea of logical implication, so a conditional expression. So if A, then B. The core realization is that logical implication has an established meaning in a formal logic setting, so in math and science and tech, but it also has an established meaning in normal conversation. The problem is that these meanings are not the same. If I said, I will go to the store later if it's sunny out, I mean that I won't be going to the store if it's raining. It's clear and unambiguous. But if my math professor made the same statement, you may very well see him slogging along in the pouring rain to get to the store later. In a formal logic setting, logical implication does not close the possibility of the inverse statement being true. Just because I will go to the store if it's sunny doesn't mean that I won't go to the store if it's not sunny, right? And there we have a contradiction. I'm both going to the store and not going to the store in different contexts. The real skill is not understanding what the various meanings of logical implication are, but in which situations each should be applied. So suppose that your high school English teacher tells you to write an essay. And suppose further that your teacher tells you that if you write a 5-paragraph essay, then you will get an A. Does this mean if you don't write a 5-paragraph essay, then you won't get an A? Absolutely not. This is a formal logic setting because it's an official assignment. But even if your grade was on the line, I claim that you should never write that 5-paragraph essay. 2 years ago, so as a junior in high school, I was faced with a similar decision, except instead of an essay, it was a lab report. We had the option. I had the choice of using the equation in the book and wrapping up my data in an hour or so and just finishing. Instead, I chose to derive the necessary equations numerically using some software that I'd never used to generate some plots that corresponded to my trials. All in all, it took 2 full days of work. But in the end, I realized that I learned more than I would have otherwise. More importantly, though, I learned that numerical simulation was something I enjoyed, and something I enjoyed so much that I'm considering it for a career. A solid foundation in logic is, I think, synonymous with reasonableness. A reasonable person can evaluate both the human and technical components of a situation before coming to an informed and rational decision. But the modern idea of smartness emerges when that reasonableness is combined with a streak of rebellion that seeks to continually subvert the expected while honoring every last constraint. I like to say that I don't give up. I believe that within the constraints of a math and computer science double major, there's still space for proficiency in writing, there's still space for jazz, a piano, and there's still space for art and poetry. So when every day I sit down at the piano, I completely fail at jazz improv. I can't just say that I'm a math and science guy and give up. That would only be looking at the center of the box of constraints. The logic opens up the corners and edges so that often the improbable is possible. And in a society where logical argument permeates not just science, but communication in general, the most effective individuals are the ones who can understand the depth of logic in any situation and act in a way more creative than before. I officially learned logical implication this year in my math class as a freshman in college. Why aren't such important concepts being taught earlier? Why aren't the subtleties of human communication made explicit rather than left for the astute student to infer? I believe that if we wove the complex but important concepts of logic into elementary and middle school classrooms, we can not only revamp how students think in their math and science classes, but how they thought in all of their classes. Crucially, we could allow those students willing to learn to think more deeply and more creatively than we thought possible. Some would argue that the key to success is thinking outside the box. But in the end, we realize that whatever lies outside the box is yet another distraction from the more interesting, more useful, and more spectacular solutions that lie inside. Thank you.